In the Prodigy I3C Exerciser and Protocol Analyzer graphical user interface, once the connection is established between the hardware of the unit and the software, the user can go for configuring the controller and target using the Exerciser View Bus Configuration window. This window is used for configuring either the internal Prodigy target or controller as well as the external DUT to the I3C network in the software. This external DUT can either be a controller or target depending upon the user case. But before jumping on how to do the configuration of controller and target to the network, let us understand what is a controller or target as per the I3C concept. In I3C, the controller is the bus manager or the bus owner that generates the clock. And this issues the start and stop for all the transitions and issues the common command codes as well. This handles the in-band interrupt or the IVA from the targets as well as issues the dynamic address assignment to all the targets in the network. So in summary, what exactly is a controller is, controller owns the bus and controls timing, addressing and communication flow in the I3C bus. Now coming to what exactly is an I3C target. The target is a responsive device that has unique PID and it addresses its capability using the BCR and DCR register values, and this also receives a dynamic address assignment that is assigned by the controller prior to any transition. If the target want to communicate anything on the bus, so this happens using the IBI or the in-band interrupt. The target can never generate a clock or never start a normal transfer also. So, in summary, the target is a peripheral device that responds to the controller and optionally requests services through the in-band interrupt or the IBI. Now coming to the Prodigy I3C Exerciser and Protocol Analyzer bus configuration. So we have the device setup option here, which allows the user to choose whether they need to configure the controller or target. Internal to the Prodigy unit, that is using the same hardware unit, the user can configure one controller and 3 I3C or I2C targets, or one controller, one secondary controller, 2 I3C target or I2C target. So using the same software, there is the support for legacy I2C mode as well. So for this video, we will be configuring one controller and one internal Prodigy controller and 3 internal I3C targets to see how the configuration of controller and target is done in this window. First, we go for configuring the controller. So for that, the node type is chosen as controller. And since the controller in this scenario is an internal one, that is internal to the Prodigy hardware unit, the interface is chosen as internal. So interface is the option given to distinguish between whether the controller or target that is getting configured is either an internal one, internal to the Prodigy hardware unit, or the external controller or target. So when the user want to configure any of the internal Prodigy controller or target, the user can go for choosing the interface as internal. When they want to configure the external DUT or their own controller or target, they can choose the interface as external. Next is the termination option. So this is an option that is given to the customer for flexibility of choosing whether the pull-up resistance from the Prodigy should be added to the network or not. So internal to the Prodigy hardware unit, there is a pull-up resistance of value 2.2 kilo ohm that can either be selected on or off depending upon whether the customer external DUT has a pull-up resistance enough to keep the logical high or not. Next comes the voltage option. So voltage, we have the flexibility for varying from 0.9 to 3.4 volt in steps of 5, 10 and 30 millivolt. And the last one is the trigger mode. In the Prodigy I3C-EX-PD hardware unit, there is an SMA pin that generates a 100 nanosecond pulse whenever the user-defined trigger condition is met. So this pulse can be fetched into the scope to analyze pre and post trigger events. And using the same SMA pin, the user also have the provision to give a pulse to this SMA pin, which takes in as an in-band interrupt and force the controller to give a response for this in-band interrupt. So once the configuration for controller is done, the user can give add device. So the user will get a pop-up showing node added successfully with node ID 0. Now if the user go to the option of I3C network in the top, the user can see whatever configurations they have done, whatever configuration for the controller or target that is configured and added to the network. Again, we'll go for configuring the I3C target. So for that, we are choosing the node type as I3C target. And interface is again chosen as internal. As for this video, we will be configuring 3 internal targets that is available in the Prodigy. Termination is again kept on and static address is given as 45, and for the internal Prodigy target, the user can give any static address of hex format. And again, the voltage is chosen as 3.3 volt, that is the same controller bus voltage which we have configured previously. And the last option is the target type. So for all the normal scenarios, the target type will be the normal target. The dedicated target is an option given for those type of sensors, specifically camera sensor, which uses the I3C pixel transfer protocol for maintaining the transfer of the configuration register values. And once the configuration in the device setup is done, for the target, the user has again the option for configuring the BCR, DCR as well as the PID register values. So BCR or the bus characteristic register is an option or an 8-bit value that is used for identifying what exactly this particular target is capable of in the bus. Whether it is HDR or SDR capable, whether it can support the IBA request or not, and whether the IBA data payload is available or configurable or not. So all these configurations can be done in the BCR. So using the BCR, the controller will come to know the capability of that particular target in the I3C network. And next is the DCR, that is the device characteristic register. So this particular register value is an again 8-bit field which gives the idea to the controller that what type of device or what type of target exactly it is. Is it a sensor? Is it like a SSD? Is it like a power management IC? Or is it like a PMIC slave? Or is it like a hub? So the user can set this as per their duty. If the user is configuring the internal target, then the internal Prodigy target can either be characterized to generic or memory DCR. Then comes the provisional ID, which is a 48-bit field value. Again, this gives an idea to the controller who exactly is the vendor of the specific target. So if the vendor is a MIPI member, then the user can choose the manufacturer ID from the drop down. If not, they can set it to the custom value and give the part ID, instance ID and vendor defined values for this particular field. So once the register is configured, the user can go for adding the device. So now again the pop-up is showing that the node added successfully with node ID 1. Now if the user again go and view the network, they can see the target I3C target is also now configured to the network. So using this I3C network, the user will get an infographic representation of whatever controller or target they are configuring. So similar pattern, we'll go for configuring again 2 more I3C targets. So choosing the interface as internal, termination as on and static address as 55 and the register value. The internal target, all the 3 internal I3C target is capable of HDR mode. So we are selecting the bit 5 as HDR in the BCR or the bus characteristic register value. And the DCR this time we are choosing it as generic and we are giving the part ID this time as a unique value of 2. Once the register configuration is done, again we are adding the device and we can see it in the network. 1 more I3C target is added to the network. Similarly, we'll go for adding 1 more I3C target and go for configuring the register values again. And we'll add the device. So now if you see the I3C network, the user can see 1 controller and 3 internal I3C targets are added to the network. So similarly, the user can also configure their own external controller or target to the I3C network. So how many controllers or how many targets that can be added to the network is again another question. So as per the I3C specification, only 1 controller can be active in the bus at a time. So the user can configure their controller as a primary controller or an active controller or the secondary controller with the Prodigy controller as the active. How many targets can be configured into this I3C network? So how many targets actually depends upon the capacitive load of the entire bus. So as per the MIPI specification, the total bus capacitance should come around 50 picofarad. So the user have the flexibility to add many number of targets depending upon their capacitive load, which contributes to the total capacitive load of the bus. Now once all this configuration is done, instead of configuring it every single time when the user is opening the software and establishing the connection, the user can just save this network. And once it is saved, they can just directly load the network once the connection is established between the hardware and software. So this is how the I3C controller and target configuration is done using the exerciser view bus configuration window and how the user can view the same in the I3C network once the configuration is done.